Statistically Significant Mini Project 2, A Day in the Life as a Robotics Engineer. So what is robotics technology? A robot is a programmable mechanical device that performs tasks and interacts with its environment without the aid of human interaction. Robotics consists of a sequence of phases during which mechanical engineering, electrical engineering, and computer science are integrated within a project. This process is very important because each discipline of engineering must have a deep understanding of the interplay between the separate systems as they relate to the robot as a whole. A day in the life of a robotics engineer includes attending lots of meetings with each discipline group to discuss their goals and parameters and create a schedule of their design process to be able to finish the project by a certain deadline. The first step in the design process is to define the problem, which includes discussing specific requirements and the purpose of construction. The next step is research and designing. In this step, they will gather information such as mechanical engineering will design the physical aspect and build with the cost and resources available. They analyze all physical limits that then will be integrated with other systems. They do so by starting with computational tools to design and create physical properties to optimize the limits within the given parameters, to test the strength and thermal properties of the given resources and design to make sure it meets the standards physically. The next step in the design process is creating the prototype to test the design. Once the design has proven to work and fixed of minor problems, they will build the actual robot. The next step is programming the robot. Electrical engineers are responsible in creating an electrical layout that provides energy throughout the system. This layout also provides pathways that send information to and from the control centers, making sure the system is responding with any given commands. After all specifications are met, the schematics are complete, the process is then finalized with the software engineers. Software engineers are the ones that put the brains in the system. They test the codes that manage the sensing, planning, control, reasoning, and learning of the system within its given parameters. Once all the requirements are met and tested, it can be finalized. The final step in the design process is to evaluate the robot, in which they evaluate how well the design functions, aesthetics, and what can be improved. So now that you know a little more about robotics engineering, it's time to discuss how statistics plays a role. In building the robot, they need to know what kind of materials to use, which include testing strengths of materials, which is statistically shown in graphs and data. Another example of how statistics is used is finding the confidence interval of the robot, which determines how well the robot actually functions, which is gathered during the evaluation of the robot. One of the grand challenges that robotics can be used is engineering better medicines, which include building prosthetic arms and legs that actually function and move, and building pacemakers. Robotics is also involved in reverse engineer of the brain, as seen on CNBC, that they have already created a robot that functions as a human. Lastly, robotics engineering can also be used to engineer the tools of scientific discovery, such as rovers on Mars that collect data and roam about planets.